Good morning, class. We are done the second week today. Glad some of you guys made it this morning. Here we are on Friday, day 9. You know what that means? We have 9 more days to go. Okay, and then you guys are done. So let us start with land acknowledgement. Okay, we acknowledge we are hosting the lands of the Mississauga of the Anishinaabe, the Haudenosaunee Confederacy, and the Wendat. We also recognize the enduring presence of all First Nations, Métis, and Inuit people. Okay, so agenda for today. I said it yesterday. Today is, you guys will have access to Unit 3 test, right? And I put hot links here, application, thinking, communication, right? But also too, it's in, as you can see there, it's in the assignment of Brightspace. Okay, so what I'm going to do is I'm going to shift this to see that I'm going to make sure I can see myself as a student, so I can see what you guys can see. Okay, so the test is today, Unit 3 test on exponential functions. I click on that. It should take me to the test for application, as you can see there. I go back to the beginning, and then thinking should take me to thinking. Right, there you go for thinking. And then when I go back, it should take me to communication. Okay, that's due. And I believe it tells you when it's due. When is it due? It's due midnight. Okay, 11:59 today. That's midnight. Okay. So that is the quiz. Sorry, not the quiz, the test. Okay. Also too, you can also go to assignments. I'm gonna show you guys again. You can go to assignments directly up top here. And you can find, this is, I'm looking as a student, so obviously I did not do, it says here, Unit 1 test, I didn't submit it because I'm not going to do it. Unit 2 test, I didn't submit it. But you can see Unit 3 test right here, it's available. Okay. Okay, so it's right there for you guys to work on. But right now, we're going to the new units, right there, new unit, which is trigonomic functions. Okay, so we keep going. That's why you got to stay on top of things. It says 6 to 8 hours a day you have to be on this course. You can't, and you always have to check your emails. Make sure you go on, like you guys are here, make sure you come to class every single day to the Zoom session, because you can hear what I'm saying, you can see what I'm showing you on the screen. If you missed the Zoom session, go watch the video, please. Okay, come back. If say you were not here, watch the video, go to the announcement section. You can see what's happening for today. Okay, some people are sending me emails, sir, I missed the test because I forgot. That's not an excuse. What that means, you probably didn't watch the Zoom, because I would have reminded you, or you didn't go onto the Brightspace. If you follow the student handbook, you need to be coming on Brightspace 6 to 8 hours a day. If you're stuck, send me an email. Don't wait till I send you an email, then you send me an email and a reply. Don't wait for me to send you an email saying, oh, where's your test? And then you send me a reply, because I'm sending you the email about when your test is, where's your test, after the test is already done. Okay, so it's not really makes sense to send me a reply after the test is already submitted or already closed, and then you say, I have an issue. Send me an email in the day. Like today, if you're doing the test, if there's some kind of issue, you can't access something, send me an email during the day. Don't send me the email the day after when it's already due. Okay, you have to show initiative. That's part of being responsible, showing initiative. Okay, all the learning skills you need to have. Okay, so please do that. Okay, so now we're going to learn today trigonomic ratios, obtuse triangles, applications of trigonometry. Okay, there's a worksheet. So there's just one worksheet for today that you want to do before you do the quiz. And the quiz for these things here are also due 11:59 p.m. So you have two things, the quiz and then the test, which is in 3 parts, okay? And as usual with the quizzes, you get 2 attempts. So now the worksheets are not for marks, guys. Please, I've been saying it. Everyone knows it's if you go in the worksheet, it says not for marks. It's for practice. That's what it says here. Not for marks. It says that right there. I'm saying it so many multiple ways. So when it says not for marks, which one are you going to use? What's the more priority, the test or the worksheet? The test is for marks. The worksheet is not. The worksheet, do a couple questions. If you feel comfortable, then do the quiz. You don't have to do every single question because it's not for marks. I keep saying it right there. Every day I say it, not for marks, right? Not for marks. Every day I'm saying that, okay? Every single day I'm saying it, not for marks. And when you open it up, it tells you it's not for marks. Again, you need to work on the test. And the quiz is in the practice quiz indirectly helps you. Okay. So I'm not marking it, but it indirectly helps you for the quiz. And then okay. So let's get on to the content. And let's see here. Oh, number 4, unit 4. And we got access. Okay, you guys got access. Okay, so here we go. Video 1, lesson 1, trigonometrical ratios. Basically, we have a few videos here, right? We talk about SOHCAHTOA. You guys should know that from grade 10. SOHCAHTOA trying to find the sides, SOHCAHTOA trying to find the angles, sine law, cosine law. I think these are new for you. Did you do cosine law in grade 10? Anyone? I'm just trying to remember if it's grade 10 or grade 11 college. Anyone? Okay, you guys did a cosine law. Okay. Well, I guess this is review a little bit. And then there you go. There's the cosine law. There's and then the sine law. Okay, so let's get into the video. So let's look at the refresher. Let's start off with the sine, the SOHCAHTOA. So I'll probably play like maybe 10 minutes of each, just so we can get an idea. And basically, that would be the lesson for today. So let's get into.
Okay, here's a lesson on how to use sine, cosine, tan to find missing side lengths of a right angle triangle. Remember, sine, cosine, tan are the 3 primary trigonometric ratios that only work for right angle triangles. Okay, so what we discovered last lesson was that each angle has its own unique sine, cosine, tan ratio that never ever changes. Okay, before I explain what those ratios are, first of all, if angle.
Okay, so I know we're talking about something maybe you guys may remember or don't remember, but it's gonna come up in grade 12. It's gonna come up. SOHCAHTOA even comes up in physics. Okay, with when you're talking about forces and stuff. So you need to understand that. Okay, so like we said here, the SOHCAHTOA is sort of a way to remember that sine is equal to opposite over hypotenuse, and the cosine is equal to adjacent over hypotenuse, and the tan is equal to opposite over adjacent. Okay, and we're looking at, when we say opposite, we're always looking at from the point of view of the angle, right? So the angle looking this way, that's my opposite, and then 90 degrees from that is adjacent. The longest side is always the hypotenuse, okay? So in this case here, if I'm looking at it from this angle, this is my opposite, this is my adjacent, and this is my hypotenuse, okay? So that's the basic that we need to know. And then we use this information to either to find out the side of the triangle, the right angle triangle, or the angle of whatever right angle triangle or whatever angle you need to find, okay? So let us continue.
So if theta is our reference angle, we have to be able to label our triangle. We have to be able to label the opposite side, the side opposite the angle. So opposite of theta is over here. Adjacent to theta is the side right beside the angle.
Okay, so we're gonna fast forward a little bit. There's your cosine, which is adjacent over hypotenuse. You can see there. He's highlighting it. And then that's your tan. Oops. Right? Okay, so now we need to get into some examples of how to calculate. Okay, angles. Okay, so let's look at this one. Oh, what you also have to remember, it's really important to remember this. Okay, remember this. Okay, you have to label all the angles in capital. So all the angles are in capital. You need to know this because it's going to come into effect when you go into the cosine law and the sine law. Okay, so the angles are at the corners of the triangle and it's labeled in capital A. Now the opposite to that angle is labeled the small letter of that big letter. So if we call this A, capital A, this is going to be little a. If we call this capital C, this is going to be little c. If we call this capital B, this is going to be little b. And it doesn't matter if we use A, B, C or X, Y, Z. You have to follow this structure. Otherwise, you'll make mistakes because they go together when we do the sine law and the cosine law. Okay, the formulas for that. So remember that.
Angle B, opposite angle B, the side gets labeled with the lowercase b. And same thing with C. Okay, so let's practice using trig ratios to find side lengths. So,
okay, so he wants to practice here. And so basically what you can see here, you want to find the length, okay? And what we're going to do here is label certain things. Okay, this is going to be the opposite, always for opposite, because I'm trying to find, and if I'm trying to find side B is actually opposite. It's over here. So I'm going to label that B, okay? And opposite to C over here, that's side C. And then this one here is side A. See, it's all lowercase. Okay, let me make this one lowercase. Okay, so what I want to find is side B. So what I need to do is find the ratio that involves side B. And side B is opposite according to this angle here. So it looks like, and the only side I know is the hypotenuse. So hypotenuse, so it's not going to be tan. We're not going to use tan because there's no hypotenuse there. It's either going to be cosine or sine. But we're not going to do cosine because cosine is asking for adjacent. We want to have opposite in the formula. So that means it's going to be sine. So therefore, we're going to write down sine 40 degrees is equal to opposite, which is B, over adjacent, which is 8. Now, what we want to do is isolate B, get B by itself. And if we do that, when B is by itself, that means that 8 goes there. I'm just rearranging it so to keep everything on the one side. So it's going to be sine, or I can write like this, 8 times sine 40 degrees. Okay. And whatever that answer is, will give you my side B. Okay. 8 times sine 40. Okay, so let us go through that example. I'm gonna just step it through. So there you go, he labeled it side B. Okay, there's your adjacent and your hypotenuse. Okay. So, oh,
Struggling with math? Hug it. Tough math class? Hug it. Just not.
okay.
of b over 8.
Okay, so that's what I wrote, sine 40 is equal to b over 8. And if you fast forward, he's actually even going to show you how to put it in the calculator. So I'm going to play that out too, because you guys need to see how to put that in the calculator.
Okay, so the sine of 40, there is a unique ratio for that. Okay, let me just bring up my calculator here, just so I can show you what that unique ratio is. So bring up my calculator. I should have done this earlier. Sorry.
Okay, I'm not sure why he's showing you all this. Let's see what he's trying to show you. Yeah, it's I don't want to get confused. So that's it there. Sine 40 equals 8 b over 8. And then he isolates. He types in sine 40 on his calculator. Okay, that's one way, and it equals to 0.6427 on this side. Then he brings 8 over to that side times 0.642, and then he gets the value of, there you go. Right? So what I would have said that he didn't do. Yeah, your calculus should be in degrees. What I'm going to say he did wrong is that you see this part here. I wouldn't have done that. Like I told you, I said 8 times sine 40. When he did sine 40 here, he rounded. You can see his answer up there. It's 0.6427876,097, and here he rounded. So if you do that, now when you calculate what the side is, you're going to be rounding. So your answer for B is not going to be exact. That is the reason why I wouldn't do that. I would just do 8 times sine 40 and then see what we get. Okay. Instead, he did sine 40 and then now it's reduced. So it's not going to be as accurate. Okay. So then you get the answer. The answer is 5.1. Okay.
You could just press on your calculator 8 times sine 40. Okay, you don't have to show the value of sine 40.
Okay, see what he just said. He just said what I just said. Just type 8 times sine 40. That's good. Okay.
Each time. Okay. Okay. Let's do another example. Find x.
Okay, this is going to be a last example. Then we're going to go on to something else. So here, you can see you're trying to find x. Well, if we're trying to find x, this is my angle over here. If I'm looking this way, from there, this is opposite, right? My bad, I'm writing opposite weird. That's not an O. So that's O. And then my x is actually my hypotenuse, right? And then over here is my adjacent, right? And I wrote it as A because here is A, capital A for the corner. We didn't even label this side, so that's fine. But this side, the hypotenuse, which I said is H, is actually small b. Okay, but we'll leave it as X. Okay, so now what we want to do is write we're going to use which trig ratio will help us solve for X. Well, it's not going to be tan because tan has no hypotenuse in it. So it's either going to be sine or cosine. Okay, we want to see what, so the cosine has a hypotenuse and adjacent. And sine has hypotenuse and opposite. Opposite, we have no value. So we can't even use opposite because we didn't even know what that value is. But we can use adjacent. So adjacent, if we're going to use adjacent, that means we're going to use cosine. So that means we're going to say cos 30 degrees is equal to adjacent over hypotenuse. Adjacent is 20. Hypotenuse, we said, is x. Okay, so now we want to get x by itself. In order to get x by itself, I'll bring it over to that side, and then I'll bring this over to this side, and then I'll have x is equal to 20 over cosine 30 degrees. Make sure it's in degrees in your calculator. And whatever I get is my answer. Okay, so that's that example. I'm going to play it out and see, and let's kind of watch him develop that. So let me get this. And I'll move this, oops. I probably should just delete. I'll just move it over to the side. Over here. Okay, let's just play it out. So the key is we want to see if he gets x is equal to 20 over cos 30. Okay, so let's go.
Okay, so it's asking us to find this variable x here. Let's first label our triangle with the opposite adjacent hypotenuse. Okay, here's our reference angle right here, the one it gives us. So the hypotenuse is always across from the right angle. Opposite to 30 is over here. Adjacent to 30 is right here. Okay. This should be labeled. This should be labeled angle C. I labeled this A and B. I forgot to label that angle C. Okay. So angle C is our reference angle. Opposite, adjacent, right beside it. Hypotenuse, beside across from the right angle. Okay. So what do we know? Okay. We know the adjacent side, and we're interested in the hypotenuse. So what ratio has adjacent and hypotenuse? The cosine ratio has adjacent and hypotenuse.
Okay, so he got the cosine ratio. All right, so let's fast forward. Cos 30 equals to 20 over x, right? There you go. Now he's going to isolate x. There you go. It's still not isolated though, so that cos 30 needs to come over to the other side. There you go. So x equals to 20 over cos 30. Okay, so that's how you get that. And then when you do the calculation, you get x equal to 23. Okay, so that is how we're gonna do trying to find the sides using SOHCAHTOA. Okay, let us minimize. Actually, let me clear my screen here. And we're going to go into finding the angles. Finding angles is a little bit harder because we have to use inverse sine or inverse cos or inverse tan. Okay, so let me minimize that. Can you guys hear me? Can you guys hear me? Okay. By the way, were you guys hearing the video? This would be kind of too late to ask. You guys heard the video? Okay. Okay, that's good. Just making sure. Okay. Something's going on with my screen. It's not trying to, it is not trying to let me minimize. There's always technical issues, right? So give me a second. I'm going to stop sharing my screen for a second. Give me a second. Yeah, it helped once I stopped sharing my screen. Okay, so let me start sharing my screen again. And we got the sound going. Okay. So now we're going to look at SOHCAHTOA to find the angle. That's important.
Okay, let's continue in Chapter 7, Trigonometry of Right Triangles. This lesson is going to teach you how to use the three primary trig ratios, sine, cos, and tan. Sine, cos, tan. how to use those, how to find angle measurements. Okay, so up till now we've known how to use them to find missing side lengths, but what if I give you two of the sides of a right triangle and I ask you for an angle measure? I'm going to show you how to do that.
Sorry guys, I'm trying to maximize the screen so it's shown better. There you go. So now we're trying to find the angle using, so this is the angle here, and with the angle we always represent it as theta. In math, we'll call that usually theta, and it'll look like this. And based on knowing the sides, and we know it's a right angle triangle, we're trying to find out what angle is that or that. Okay, so let's get into it. We already know the SOHCAHTOA, right? So the angle, it can be found once we figure out which trig ratio we're going to use, right? So let's get into an example. Okay. We already know what opposite, adjacent, and hypotenuse looks like when you're looking at it from the angle. So you already know that. So, so now, okay, so here is an example, and I'm going to back up here, where say you're doing just pure calculation, you don't have a triangle, you just have a number. You say the angle is, I'm going to play it from here, tan theta equals to 2, like it was just showing there. So let's play this out from here. He's going to show you with the calculator, so just watch.
So we can label this triangle. Then how are we going to use trig to find angles? Well, if I tell you that the tan of an angle equals 2.
Okay, so that's it there. If I say cos of an angle equals to 0.31, I don't know, I'm just giving an example. Or cos of an angle or sine of an angle is equal to a half, right? Then he's going to show you how to do it in the calculator, and then we can find it out. Okay, so watch.
So I'm telling you, I remember tan is opposite over adjacent. So I'm telling you the ratio of the opposite over adjacent side is 2. How do I find that angle?
So what's he saying there is, instead of a triangle, you may have a question where I just give you the ratio, right? So, and I want you to understand there's two ways of a question I can give you. I can give you the question with the triangle, and I label a side and you have to figure out what the angle is, or I can just give you the trig ratio like this and tell you what the ratio is, right? So, oops. Something like this, if I were to draw a triangle, could be, because you don't always say in tan, so we're saying this is theta, and tan is what? Opposite over hypotenuse. Sorry, opposite over adjacent. So I can say this is my, and I don't even need to label the hypotenuse. So if this is my triangle, right? And I'm saying my tan theta is equal to 2. So looking at from here, that is my opposite, and down here is my adjacent. So tan theta would equal to opposite over adjacent. That would be 2 over 1, which is also just equal to 2. So I'm showing you what this looks like, okay? I'm showing you what this looks like in a triangle setting, okay? But, you know, this was an easy question because all you have to do is plug it into the calculator. But if I give you the triangle like this and I label it and I say find the angle, then you have to go and figure out what trig ratio am I going to use. Am I actually going to use tan? Am I going to use cos? So this is an easy question because I tell you I'm using tan. And then from there, you go into use your calculator and do inverse and you can figure out the angle. So this is an easy question. It's hard if I give you a triangle and you have to figure out which trig ratio to use to get the angle. Okay, just giving you a heads up on that. So he's going to use his calculator. Fast forward a little bit. Actually, no, I'll play it out so you can see how it punches it in this calculator.
Well, I calculate the inverse tangent of 2 to find the measure of angle theta. Okay, so all I do on my calculator, after I make sure it's in degree mode, yep, it's in degree mode.
Yep, make sure it's in degrees.
I just do inverse tangent. Okay, so that tells my calculator.
You can see he typed inverse tan. It's in your calculator. Look for inverse tan, and then he's gonna type in 2.
Calculator that I'm putting in a side ratio and not an angle. Okay, so inverse tangent of 2, the side ratio, the ratio of opposite or adjacent is 2. So if I put that on my calculator, inverse tan of 2, press equals, that'll tell me the angle measured.
Okay, so that's the angle. So the angle is 63.43 degrees. Degrees now, okay? So, so when you're trying to calculate the angles, so the inverse trig ratios, inverse sine, inverse cos, inverse tan, allow you to find the measure of the angle only in the right angle triangle. All you need to know are 2 sides, as well as know how to use SOHCAHTOA. Okay, I need to know the 2 sides of that right angle triangle, and I need to know how to use SOHCAHTOA. Then I can figure out what is the angle that I need to find. So don't get confused. It's telling you here, this this -1 exponent is not -1 exponent, okay? It's not an exponent. It's just a way to let us know, to tell us that this is an inverse function, okay? We did that in the first unit. We talked about inverse function. We write it like this. So inverse sine, inverse cos, inverse tan. Okay, it lets us know we're doing inverse. Okay, inverse allows us to find the angle of the right angle triangle. Okay.
Inverse cos and inverse tan. You can use those to find the measure of an angle in a right triangle. Make sure you can only use these for right triangles. Okay.
Okay, so let's fast forward because we have to get to another example. Okay, so here is.
Let's ride.
So I'm gonna get through this commercial. Unfortunately, it comes in when we're recording. Well, we gotta watch. Well, I muted it. So let's another 10 seconds and we'll get back into it. Okay, so now we're
Get rid of the highlighter.
okay. So now all we're doing here, this is easy because I'm telling you what the trig ratio is. I'm not giving you a triangle, so this is easy, right? So sine theta equals 10 over 26. All you have to do in your calculator is do inverse sine the angle. And I'll just write it on the screen. Okay. All right. It's just going to be theta is going to equal to inverse sine 10 over 26. Okay. Over here, this would be theta is equal to inverse cos, which would be point. That's what you're doing. And then my angle is equal to whatever I punch in my calculator. My angle is equal to whatever I punch in the calculator. Okay. So that should be simple. Okay. Because I give you the ratio, I just got to find the angle. It gets complicated when you don't have, you're just given a triangle, I have to figure it out. So this is easy, right? So let me clear that. I'll step it through so you can see what he's going to go through. There you go, inverse sine. There you go. That's the angle. The angle is 22.62 degrees. You should put degrees there so that it finishes off the question. Next one, inverse cos of that. The angle is 75.5 degrees. Okay, so that's easy, right?
To do a question. So
now this is the hard one. When I don't give you the trig ratio, I just give you the triangle. Now I got to figure out what trig ratio to use. So here's the harder one, but it's still not that hard. Once you know SOHCAHTOA, it's not hard, right? Once you know SOHCAHTOA, it's not hard. Okay, so here we go. So I want to find this angle, and I know this is going to be my opposite, and this is going to be my adjacent, right? I don't know my hypotenuse. I don't know that. So the only one I can use to use opposite over adjacent. Which trig ratio am I going to use, guys? I want you guys to tell me now. Tell me which trig ratio I'm going to use. Sine, cosine, or tan? Which one? Anyone? Yes, tan. It's going to be tan because I don't have a hypotenuse. So I only have opposite and adjacent. So therefore it's going to be tan theta, which I don't know what it is, going to solve it, equals to opposite, which is 1/2. Then I get the angle by itself. And then I bring the tan over to the other side, it becomes inverse tan. And I have here 1/2. And then I figure out what my angle is, okay? So this is easy, I think, or this is review, to be honest. This is review of grade 10. So that would be it there. I'm gonna fast forward because we gotta get to the hardest stuff. Oops. So there you go. Right, he's playing it out. That's it there. That's it there. That's it there. That's it. Okay, that's my angle. 26.57 degrees. Okay, so we're gonna go to the next one. We have to get into is, yeah, let's look into the sine law. Sine law is two things. You can find sine law to find the side, sine law to find the angle. That means we're trying to find an angle. That means we're going to be doing inverse sine. And then you got the cos to find the side and cos to find the angle. That means you're going to use inverse cos. Let us go. I'm going to do 5 minutes for this. And we're going to try to get through. We only got 20 minutes left. So let's see how much I can get through in 20 minutes.
Okay, so here's the first lesson for Chapter 8. Chapter 8 is on the trigonometry of acute triangles. Okay, so Chapter 7 we worked with right triangles and we used SOHCAHTOA. We used the sine, cosine, tan ratios to find missing angles and sides. Okay, when we're working with
So when we say acute angles, that means each angle inside the triangle, no angle is bigger than 90 degrees, okay? It's less than 90 degrees. Okay. Obtuse angle is where you have a triangle where it looks like it could look like that. Okay. Where you got one angle here, it's greater than 90 degrees. So we don't have, these are just these are all, and you know, these are all acute angles. Okay. So let's get back into this quickly. So here's the sine law here. Okay. And it's important that, again, we label the corners in capital letters, okay?
acute triangles, we can't use SOHCAHTOA anymore. We can't use those trig ratios. What we can use are...
Okay, remember, we can't use SOHCAHTOA anymore because SOHCAHTOA only applies to right angle triangle. This is not a right angle triangle. So that's why we're using this called sine law and then cosine law, okay? It's not SOHCAHTOA, it's sine law, okay? And it's not cosine, this is, again, this is, mixing up my words here. This is just, I guess, it's used to find the triangles that are not right angle triangles. So let's go.
Two laws that we'll learn in this chapter, the sine law and the cosine law. Okay, those will help us find missing angles and sides for acute triangles. So this lesson is on section 8.1 using...
Okay, let's fast forward. Let's get into the meat and potatoes. Okay, and over here you can see we have to label the sides all in lowercase, so that's important. Okay, as we said when we're talking about SOHCAHTOA. So opposite to B, capital B corner, is small b side. Opposite to A corner is small a side, and opposite to C corner is small c side. We need to know that because this helps us to set up our formula. If we do this wrong, then our formula is going to be incorrect and we're not going to solve it properly. Okay, so here is our sine law. This is basically the ratio of each side to its opposite angle. Okay, so the ratio, you can see A, side A over sine angle A, side B over sine angle B, side C over sine angle C. This ratio. So these ratios equal each other. And basically you're going to use this in order to solve this triangle. Okay. It doesn't matter if we use A, B, C, we could use X, Y, Z, but we'd also know that X, Y, Z, that means opposite to that would be the lowercase. Yes, the bottom are angles. That's a capital A, right? So that's the angle. Okay. So let us continue from here.
Ratios are all equal. So even though there's 3 ratios in the sine law, and then you see 3 parts, you only ever use 2 parts at a time.
Okay. So you're only going to use 2 parts because you're trying to solve something you don't know. Okay. So we have to get into an example in order for you to see that. Right? We can have A over sine A equal to C over sine C. It all depends on what we have in our triangle. Okay. Will help us determine what we're going to use. Okay. So we got to see an example. Here's an example right here. Okay. And I believe we're trying to find what we're trying to find here. You're trying to find that question mark. Okay. So actually, let me back up. So I think he's telling you when to use it. Let me back up. Play it from here.
So we can solve any equation that only has one variable. Okay. Let's just go ahead and do a question so you can see how this works. Okay. Well, first of all, let's clarify when you can use the sine law. Okay, sine law can be used in 2 instances. Instant 1.
Okay, so this is showing you when you can use a sine law. Okay, so I have 2 angles, right? And I'm trying to figure out a side, but I have a side that's opposite to one of the angles. Okay, as long as I have a side that's opposite to one of these angles, I can find the other side. Okay, in this case here, you have 2 sides, but I need to have an angle that's opposite to one of the sides. Okay, that's when I can use sine law. If I have all 3 sides and no angle, then I can't use sine law, right? I can't use sine law. Okay, so okay, yep, yeah, but then we're trying to find the angle. So watch, let's go through the example. Okay, we have to go through an example. Let me fast forward. Okay, you know what? I think you guys should hear it. As I said it, I want you guys to hear what he said too. That way it's in both versions of how, when you use the sine law. So I'm going to play this one out.
Instant 1. It can be used to find an unknown side. Okay, when 2 angles and a side are known. So if I know 2 angles and a side, I can use the sine law to find another side. Okay, like once again, if you look, I have 3 pieces of information. I can solve for the 4th using 2 of these ratios. Okay. The second instance when you can use the sine law, you can use it to find an unknown angle. Right here, if 2 sides are known, and the angle opposite one of the known sides. So 32, side 10 is opposite of angle 32, and I have another side, and I want.
Remember I said that as long as you can have 2 sides, but as long as I have one angle that's opposite to one of the sides. For example, if I had an angle inside here where my mouse is, then I can't use sine law because that angle is not opposite to any of these angles, or it's not opposite to any of these sides. So I can't use sine law to solve this equation, or sorry, solve this triangle.
want to find an unknown angle. So those are the two cases you can use the sine law. And remember, you use these with acute triangles. Okay. So let's do two examples of finding a side length using the sine law. Okay.
Okay, so here's an example. Let's get into the example. Okay, it's saying, what is it saying here? Find the length of C, right? So we're trying to find C. Let's move this up there so we can see. So we're trying to find the length of C, length of side C. So side C would be over here, right? Because that is opposite to angle C. So if we're trying to find side C, okay, so we're gonna have C as a numerator. So I'm gonna write it like this: side C over sine C, capital C, but we know capital C is 52. So I'll just write it here like this, big C, okay? And then we have to make it equal to another side and another angle. So what sides do we know? Well, we know this side here, that side is B, so we know B. And do we know angle B? Yes, we do. So we're gonna set it to that. We're gonna set it to B over sine of angle B, okay? So now all we do now is plug in what we don't know. So small c, and then angle C is 52 degrees. It's equal to side B, and side B is 2.5. Okay, so something in the chat. Yes, you're right. 2.5 over sine 62. Okay, degrees. So then that being said, you're gonna get C by itself. So if I were to get C by itself, I bring the sine 52 over to the other side, it's gonna be 2.5 divided by sine 62 degrees. I'm coming off my screen there a little bit. 62 degrees times sine 52 degrees. Okay. And when you do that, you can get your angle, sorry, your side C. Okay. So 2.5 divided by sine 62 times sine 52 gives you side C. Okay. So he's going to go through that. Let me just clear the screen so we can walk through that with him. Okay. I'm going to step it through. There you go. That's your side C. We know that side over there is B. Oops, commercial. Okay. I'm just gonna pause through this commercial. We may go a little bit over time because we still have to talk about the cosine law. Not another commercial. Oh my God, 2 commercials. Okay, skip. Okay. So he's writing the whole thing out. We're not going to use any of the A's because we don't have side A or angle A. He's just writing out the formula. Okay, so let me pause and fast forward some stuff here. Yes, so we're going to use we're going to use side B and angle B. So 2.5 over sine 62. So we're not going to use this, and we're going to use this. And I already explained that. So now I can isolate and get C. So C is going to equal to 2.5 divided by sine 62 times sine 52. So so it's showing you it's going to have that and that. That's what we're using. And then it's showing you we don't need that because we don't have any of these values. We don't have anything for A. So that's what I showed you from the beginning. And now he writes it out, 2.5. So bring the sine over to the other side. And I think he punches it on his calculator. Let's see. So 2.5 times sine 52 divided by sine 62. There you go, right? So now he's punching in his calculator up here to the left, right? So you can see he punched in his calculator 2.5 times sine 52 bracket, close, make sure you close the bracket, divided by sine 62 equals to 2.23. So that side C is equal to 2.23. Okay. So that's what you're doing there. So this is how to find a side. Okay. I'm not gonna do this one. This is similar to the previous one. Okay. It's saying find the side, side A. Well, there's side A. You label the side A. So if I'm looking at side A, what do I have? I'm just gonna go through this quickly. What do I have? I have A's, right? I have angle A. So I need angle A in order to find side A. What do I have? I have, oh, this is a tricky one. I can see why it's tricky. I don't have angle C. I don't have that, but I have side C, right? But you know what? I can find angle C, right? Because if I know two of these angles, I know all the angles in a triangle equal to 180, right? So I can find angle C, right? So angle C, right, is just equals to 180 minus 46 minus 52, right? Yeah. You said 146, it's actually 46. And yeah. So now what's the answer then? I want to know what's the angle C. Okay, so angle C is equal to 80. If that's the case, is that true? Oh, sorry, it's 54. I don't know. Oh yeah, you're right. It is okay. It's 46. Yeah, 50. Yep. So if angle C is equal to 80, right? Now I can basically use my C's in order to find my side A. Okay. So what I would do is we'll write down what we don't know. So A over, now we're going to say the side or the angle A. So it's going to be sine 54 equals to what we know. We know side C is 11 over sine, and the angle of C, we know what that is. We know it's 80. Okay. So we get A by itself, as usual. Bring the sine 54 over to the other side, and you're gonna have 11 divided by sine 80 times sine 54. Okay, and then that would be your answer. Okay, so we're gonna stop this for now because we're done with, and we're gonna get into the angle versions. Okay. Okay, so we did the angle version. We're getting close to the time, so I'm going to go overtime so I can cover this stuff for you. So the sine law, in order to find the angle, since we know how the sine law works, this shouldn't take long to go through with you guys.
Very similarly, okay? So if I ask you to find angle V,
Okay, give me a sec. I'm trying to get this all squared up for you guys to see properly. It's always like that at the beginning. Okay, so we're going to use the sine law now, but now we're trying to find the angle instead of trying to find the side. So it says here find angle V. So that's angle V. So we use the same thing. If that's angle V, I need to know side V. Okay, there's my side V. Okay. Then, and you see how we're using not ABC, we're using T, V, and U, because you don't have to use just ABC. but it goes with it, right? So if this is my capital T, which is my angle, my opposite to that would be my side, which would be small t. Okay, so that's small t over there. I don't have anything for u, but I have my t's. I have my angle t and my my side t. So I'm going to use t in order to figure out what my angle v is. And I also need to have the opposite to my angle v, which is right here, which is side v, will be lowercase v. Okay, so then I write down what I know. Okay, so this is my side v over my angle v, and I'm trying to solve my angle v. Okay, let me just see something here. No, I'm not going to confuse you. You know what? I want to show you something else. You can also write this so you can see. You can always also write this sine A over A like that equal to sine B over B like that is equal to sine sine C over little c. You can also write like that. It means the same thing. Okay. And the reason why you write like this is if you're trying to find the angles, then you put the angle up top. If you're trying to find the sides, then you put the sides up top like this. In this case, we're trying to find angles, so I'm going to put the angle up top. Okay, it doesn't really matter. I can keep it like this. It's not going to, but it just makes you think, okay, if I'm trying to find the side, that means I'm going to put my unknown up top. If I'm trying to find the angle, I'm going to put my unknown angle up top. It just helps you to organize your thoughts, right? So in this case, I'm going to put sine v up top over little v. Okay. And I'm just going to erase this stuff over here. Just to show you, you can write like that. Okay, and then it's going to equal to, and what we're going to use is t. So we're going to use sine t over little t. So let's plug in what we know. So sine v we don't know, but we know the side v, which is 11.1. 11.1 equals to sine t, and angle t is 31 degrees, over side t, which is 5.8. Okay, so now we're going to get the sine v by itself. There's a lot of, I'm going to rewrite this over here. So sine v by itself is going to equal to sine 31 divided by 5.8 times 11.1. Okay, and whatever I get there, then I'm going to get the v. So we always write this, angle v is going to equal to, now what's going to happen, this is the part where you have to do some calculations maybe beforehand, but this whole thing is going to be under inverse. So I'm going to have here inverse, right? There's inverse right there. And then this whole entire sine 31 5.8 times 11.1 goes under inside the bracket. So I'm going to have here sine 31 divided by 5.8 times 11.1. Okay, close bracket. That whole thing, then inverse it, gives me my angle V. Okay, so sine inverse of the bracket sine 31 divided by 5.8 times 11.1 gives me my inverse, or gives me my ratio, and I'm going to get the inverse of that. Okay, so I'm going to erase some of this stuff, and I'm going to play it out. Okay, and then we'll see him get to the point I got to. Okay, so let me just move that. I'll just move it up here for now. Okay. 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 So let's play it out so you can see if we get to the same spot. Okay, fast forward some stuff. There you go. So you wrote it out. So he using the C, using the T's, like I said, right? Oh, actually he's gonna write out the whole thing. So let's, but he's gonna realize you're not gonna use any of the V's, you're gonna use just the T's. There you go, 11.1 for the side V. And 5.8 for the T for the side, and then 31 degrees for the angle for T. And you're gonna cross out U because you don't need U. That's all you're gonna use, U's and T's. Okay, he's writing it out, the formula, so you can see, right? So now he has to isolate the V, right? So let's go through the isolation of V. Okay, what he's doing here is doing cross multiplication. You don't have to do that. I mean, I'm just showing you how it's just basically isolating your variable that you need to find, which is sine V, just isolating that. So when he isolates it, there you go, right? So I have here 11.1 times sine 31 divided by 5.8, which is what I have here, okay? This is what I have up here, same thing. So now he's gonna have to do inverse of sine in order to get the angle V. Okay, so he's writing it out. So what he did, what he also did was, you know what? He actually just plugged this in his calculator up here. You can see 11.1 times sine 31 divided by 5.8, and he got that, and he got this, right? So you could have did that up here too, and then get the inverse. You could do that. That's fine. It's no big deal. It's probably even less complicated than what I did here because you could make a mistake with your, you know, with your brackets. I tend to think someone may make a mistake with the bracket here, and you have to put a bracket over here for around the 31. So this way is probably fine to do. The only thing is this rounding, so you could get the angle off, but it's fine. As long as you have more decimal places in your answer. So there you go. So he's going to show the inverse sine of that. And then basically the inverse sine, which I showed you here, of all this stuff here, which is basically 0.9856. And then that's the answer. Okay. He's punching in his calculator over here. Inverse sine of that. The angle is 80 degrees. Okay. So that is the way you do for the sine law to find the angle. So that's one example. We don't need to go through another example because it's going to be similar. So we got worksheets for that. Let us go to the cosine law, which is over here. We'll do that. And let me clear that stuff off to the side.
Okay, here's lesson on section 8.2 using the cosine law. So we're continuing with chapter 8, trigonometry of acute triangles. In section 8.1, we learned about the sine law, which you can use to help solve for unknown sides or angles of an acute triangle. Today we're going to learn about the cosine law.
Okay, so there's a reason why you have two of these laws, cosine law, sine law, because in not all situations for acute angle, you can use the sine law. Therefore, you have to have another law in order to find out the other ways. So if I'm looking at here, this shows you the ways in which you will have to use the cosine law because you can't use the sine law. In this case here, you can see I have two sides I know, 5 and 7, and the angle is in between them, right? So when I have this situation where I have a side, angle, side, then I have to use cosine law. I can't use sine law because if I look at it, this angle here, there's no angle value here. There's in the angle, there's two unknowns. I don't know this angle and I don't know this angle, right? Which which maybe you can get away in the sine law, but sorry, I can't solve anything because this angle which I do know is opposite to the side I don't know. Since I don't know that side, but I know this angle, but then I know this side and I don't know this angle, there's none of the sine ratios will work, right? It won't work because I need to know opposites. In this case, I don't know any opposites. None of the opposites are there. It's always one is missing, right? The C, but then I have no little c. I have a big B, but I have no little b. So I can't use sine law. So I have to use cosine law, okay? And then the bottom one, so I'll play it out so you can hear what he's saying. So I'm gonna say the same thing I said, but let's hear.
Which is useful in two scenarios when working with acute triangles, and I'll explain those in just a second. Okay, so first of all, this is the cosine law right here. There are three equations we can use depending on what is given to us in the question and what we're looking for.
So the three equations based on, like, you got three corners and three sides, right? So it depends on which one you're trying to use, right? That's all. Like trying to find angle A or B or C. That's what got three equations. Or side A, B, or C. Okay. Just fast forwarding. Okay. So here it's telling you why you're using that.
To be looking at just the first scenario. Okay. You can use the cosine law to find a missing side of an acute triangle if the other two sides and their contained angle are known. So if I know two sides of a triangle, I know this side, I know this side, and I know the angle contained by those two sides. So
he's telling you another way. This side, and this angle, then I can use cosine law. But he also is not telling you that I don't know this side opposite to the angle, and I don't know this angle opposite to that side, or this angle opposite to this side. Therefore, I can't use the sine law, so I have no choice but to use the cosine law. Okay, that's it there too.
The angle between these sides, the angle at the vertex of the two known sides. Okay, so if I know the contained angle of the two sides, okay, so I know two sides, its contained angle, and I'm looking for the other side of the triangle, the only one that I don't know, okay, I can use the cosine law. Okay, so let's look at this cosine law here. So I'm looking for, okay, if angle B is here.
Okay, let's fast forward. Let me talk about the second scenario. Okay, so you actually didn't go through that. Okay, so he's going to go through an example of with the first law. Okay, so you use a triangle DEF. Let's just go with that.
We know two of the sides. Okay, so if I know these two, I know side D and side F, and I'm looking for side E.
The real estate market is heating up, and there's no better.
Okay, let me just pause that. Okay, skip it. Let's hear it again.
Okay, the cosine law tells us that if I'm looking for E, that's going to be at the front. E squared is E.
Okay, so he's showing you if I'm trying to find the angle, sorry, the side E, right? And I don't know angle, well, I know angle E. So basically, I'm writing it out. I'm trying to find this unknown side. Here's the equation. You don't have to use ABC. You're using DEF. Now watch how he writes it out.
Equal to the sum of the squares of the other two sides that I know.
Okay, so that means the sum of the two other sides. That means 8 squared plus 7 squared he's going to put there.
So I know the other two sides. One of them is 8, the other is 7. So if I add the squares of each of those, and then subtract.
And then I'm going to subtract double those two sides, multiply together. So 2 times 8 times 7 is what I'm going to put there.
Twice the product of the known sides times the cosine.
Now I'm gonna put times the cosine of my angle that's opposite to E. Okay,
Of the contained angle. So I would have had to have been given this angle here. Let's say that was 30. So cos 30.
okay, so that is it there. So that will show me when I do this mathematical operation, then I'll get my side E that I need to find out. Okay,
Okay. So look, if I wanted to find side A, I know that A squared is equal to, so if I'm just going to find side A, I would have had to have been given side B and C and their contained angle A. Okay, so I wanted to find A.
okay, so basically if I need to know what A is, I have to know what B and C are, and I have to know the angle that's opposite to A. Okay, same thing for each of these. If I want to know I want to find side C, that means I need to know the other two sides, A and B, and I need to know the angle that's opposite to C. Okay,
I would add the square.
let's fast forward to an example. Here's an example right here. Find the length of the side. Okay, so we're trying to find A. So in order to find A, I'm going to fast forward this. The formula would be A squared, because I know the opposite angle to A. So, and I know the two other sides. So A would equal to A squared plus B squared plus C squared. So let's fast forward this so I can just get into that. There you go. Right? So that's what you'll be using. You plug that in and you find the angle. So you find the side A. Right? Because I know my side B is 18. I know my side C is 21. And I know my angle A is 61. Okay. And if I plug it in, there you go. And then I get the answer. Okay. So all this gives me this answer. I plug in the calculator, you can see up there, A squared, 21 squared. So 18 squared, 21 squared, minus 2 times 18 times 21 times cos 61, and I get 398. That's the answer there. Then I square root that. Okay, so I square root it, and then I'll get the answer, which is 19. Okay, rounding up to 20. Okay, so that would be it. So this is in order to find the side. Okay. Is there any other example? I'm gonna fast forward. Okay, here's another example. Okay, I like the fact that we're using different letters because that helps us to show that it doesn't matter if we use A, B, C, we can do D, E, F. So let's look at this one here. So I want to try and find side D, right? Well, I know my opposite to D, I know the angle. Angle D is 39. So, and I know my other two sides. So basically it's going to be my D is going to equal to, or D squared. Let's fast forward. Right? D squared is going to equal to 4.7 squared plus 3.3 squared, right? Times minus 2 times 3.3 times 4.7, and then cos 39 degrees. There you go, right? So I do all this math, and then I get a big number here, and then I'm going to square root it, and I get my answer for D. So he's going to punch all that in this calculator. So you punched in all that in this calculator. Maybe he's not done punching it in. Oh, he's not done. Then cos 39, and now he should be done now. Yeah, there you go. That's the number you get, and then you're going to square root that, which you did, which is 2.97. We can round up to say 3. Back up. You got 3. Okay, so that is it in order to figure out the length of a side using the cosine law. We're gonna go to the last one. We're going over time, but I wanna get that in for you. And this will be a quick one because all we gotta do is find the inverse cos in order to find the angle. Okay, so this will be pretty quick.
Okay, here's the third lesson for chapter 8. This is the second lesson on cosine law. In this lesson, we're going to learn how to use the cosine law to find an unknown angle when we know all three sides. Okay. Previously in chapter 8 is trigonometry of acute triangles. Okay. Previously in chapter 8, we learned about the sine law, and we learned about when we can use that to help us.
Okay, so we're gonna do finding the angle. So here's a scenario, right, where you use the cosine law. Okay, in order to find a side, and you can see here. Here's a scenario where you're gonna have to use cosine law, but you don't know any of the angles. You know all the sides, so you're not trying to find a side because you know all the sides, but you don't know any of the angles. In order to find any of these angles, you have to use cosine law, and watch how we use it. Okay. So I'm trying to find, say, angle B. Okay. So we're going to basically use the formula that you can see there. I'm trying to find angle B. So I'm going to use this formula here, which is B squared equal to all this. My whole idea in order to use that is to isolate cos B. Okay. And then I can solve it. So let's see if we can fast forward that. Okay, so let's look at this example. So how do you find A? So angle A, we don't know. Oh, this is actually trying to prove it. So we can rearrange the cosine to solve for A. So if I want to try and find angle A, we can rearrange the cosine law, and that's the key. You have to rearrange it. And he's showing you how to rearrange it, okay, to get the big angle by itself. So this is what we're going to do. Write out the formula, okay? Now I want to rearrange it. So that means I'm going to bring things over to the other side, and I'm trying to isolate the cos A. So let me play it out from here so you can hear what he's saying.
I'm going to move b squared and c squared to the other side. So I'm going to subtract them to the other side because they are positive.
See, that's what I'm trying to do. I'm trying to isolate my cos A. So I bring stuff over to the other side.
On the right, they will be negative on the left side of the equation. Okay, -2. I'm just going to rewrite that a little clearer. B squared equals -2 B C cos A. To get cos A by itself, because
okay, now to get cos A by itself, I have this -2 2BC. I'm going to take this whole thing and I'm going to divide it into all of this. Okay, so that's what he's going to do.
it's being multiplied by -2 times B times C. I have to divide the -2 times B times C.
Okay, so then he brings it over to the other side, and that's what you get. See that? This whole thing went over to this side, and I divide this entire thing. We're developing this formula now, right? So that's going to get you cos A, the angle by itself, in order to solve the angle. Now, what I would have to do is bring this cos over to the other side, and it's going to be inverse cos for this entire thing. And this entire thing, inverse cos, will give me my angle A.
Second equation, an isolated cosine of B. And if I rearrange this one, an isolated cosine of C, this is what I would get here.
Okay, so he's not actually going to inverse it yet, but that's what you'd have to do to actually find the angles. Okay, so this would be the formula you would use to find the angles of if you have all three sides and you want to find one of the angles. Okay, so this is easy. If I have all three sides, I'm going to use this formula. If I want to find angle C, then I need to know, well, you got to label all of the sides first. Make sure you label it properly, like lowercase, and then you can plug it in and you can find your answer. Okay, so let's.
What? Still searching?
So we're going to be done. I'm just going to go through one example, and then we're going to be done. So let me.
And then I subtract the square.
let me go through one example. Here's an example. Okay. So I'm trying to find angle A. So I know what all the sides are. Therefore, this is going to be side A, this is side C, and this is side B. So then I plug all the sides into the equation in the right spots, and then I can solve for cos A, and I get inverse cos, inverse cos, and it gives me my final answer. So watch. Plug it all in. There you go, right? And we know our angle, so we don't know the angle, trying to find the angle. So now I plug it all in my calculator. So he's doing it in his calculator off to the side. Okay. So this is what I get, my numerator divided by my denominator. So now I'm going to get inverse cos. A is going to be inverse cos of all this. There you go. And that's my angle. Punch it in the calculator. Inverse cos -117 divided by -180. And I get my angle A is 49.5. 49.5. Okay. So that is it. I'm gonna let you guys not go just yet, but that is the end of that lesson. Give me a second, guys, when I go back to the home page. So that is it. There's a quiz related. I want to make sure you guys can see the quiz. The quiz related to that is under quizzes. It's right here, unit 4, number 12, July 12th, that's today. Okay. The other thing too is I believe you can get it from the home page as well. If I click on here, here's a quiz. It takes it to where the quiz is. And let's see. Yeah, it takes it to where the quiz is. Okay. So everything's there. Okay. So please, I don't want to hear any excuses. I forgot, or I didn't know we had to do something today. It's, if you're not online, then that's the reason why you're not getting things done. Okay. So I think I'm gonna stop recording now because it is time. Yes, I'm gonna stop.